All right, and welcome to this video on forces and component forces. So at this point, you are getting comfortable at drawing forces, but have you noticed that all the forces so far have all kind of neatly lined up with the X and the Y, or pretty well all of them with the X and the Y axes. So we're going to deal with, we're going to invent here something called components of forces to help us deal with those pesky forces that might happen at an angle. So just as a quick, example, let's say we got a typical crate on the ground and we're pulling it, so that might be an applied force at an angle. When we draw the force diagram, I'm just going to look at only FA, even though there are probably other forces acting. This force would be at this angle here, and I've been having you draw X and Y coordinates. We can say, hey, that force is pulling to the right some amount. So here's the amount that is pulling to the right, and I'll put an arrow. I like to do dots. You know what, maybe see if I can make some better dots. I like to do dots instead of a straight line, just to differentiate the fact that this is, there we go, this is a component, and it's also pulling some amount up. So I could say this is the amount that is pulling to the right, and this is the amount that is pulling upwards. So if I was talking about how much FA is pulling to the right, I could refer to it as FAX. So, I could just put X, or I could put FAX if I wanted to get more technical. Similarly, I could say FAY. Maybe another example, one more quick example before we go to the first real example. Let's say if that applied force was pushing downwards like this. So now when I draw the box as a single dot, and I say, okay, it could be moving horizontally, and so here's my horizontal and my vertical axes. When I draw FA, just a reminder that we want to draw the forces starting from the dot, so this arrow actually goes over here, okay, and again that could be my applied force if I'm doing the pushing on it, and I would say, okay, that's pushing some amount to the right and some amount down, so I make a triangle, and I say this is the amount that is going in the X direction, and this is the amount that is going in the Y direction. I usually like to put arrows to show those directions. Okay, so let's go to our first official example here. There's a car parked on a hill, and we're going to go through these steps here. It says sketch the system and its surroundings. Well, that's kind of been done for us. Enclose the system with a system boundary, and that's kind of been done for us. And really the reason why we do, enclose that, or like put this box around it here, is then it's clear in our mind that we're drawing the forces acting on that car. We're not drawing the forces acting on the ground or acting on something else. So we're just thinking about the forces acting on that car. Then it says shrink the system to a point at the center of coordinate axis with one axis parallel to the direction of motion. Well, over here, it's parked, so it's not actually moving. But if it did start moving, which direction would it be moving? If it started moving, it would start moving in this direction. So this is different than our last examples, right? Before, I drew the coordinates along with X and Y. So these coordinates now are going to kind of look more like this one, and the perpendicular one, that one. So instead of saying X and Y, because X and Y doesn't make sense, what I'm going to do is I'm going to point out that this one here is parallel with the road. So I'm going to call that one, there's my parallel symbol. That one is parallel, and the other one is perpendicular to the road. So I'm going to call those, instead of X and Y, I'm going to call them parallel and perpendicular. So I'll do that over here. Do it one more time. It'd be like, okay, so here is my parallel direction, and here's my perpendicular direction. Okay, and the next step says represent all the relative forces, any forces that cross the system boundary, in other words, like acting on the car. With a labeled vector. Okay, so I'll go over here. So we got this coordinate and that coordinate. Now I have the ability to change color. I think that's helpful. All right, so there is a force of gravity downwards on car by Earth. There is a normal force. Which way is the normal force? And it's actually, this is very helpful now because it's going to be in that perpendicular force, because that's what normal means, perpendicular. So I have this normal force here, normal on car by the road. And since it's parked and not sliding down the hill, there must be some friction acting on it. And if there was no friction, it would be like sliding that way down the hill. So the friction must be opposing that. So I've got some friction force going this way. So I've got a friction force on the car by the hill, or by the road, pardon me. All right, now I just chose lengths of those arrows, and we'll see in a minute whether or not those are good, relative lengths of the arrows. And at some point, it's good to draw in pencil, and then if you need to change things, you can do that. All right, step 5 says indicate which forces, if any, are equal in magnitude to the other forces. Oh, actually, we're not done here. We're going to draw the components to the force of gravity here. So this is the part we're going to, maybe I'll switch to red, draw components. So in the past here, in our 2 initial examples, it's when this force was not along our axes that we drew the components. So which is the one that's not playing nice with the others? Which is the one that's not along the axes? Well, it's the force of gravity. So we're going to say, well, force of gravity straight down, sure, but how much is it pulling in the direction, the perpendicular direction? Oh, I want to do dashed, right? How much is it doing in the perpendicular direction, or dotted? So that would be in my perpendicular direction. And how much is it doing in the parallel direction? Okay, notice here, I'll just redraw it over here. You could, I drew my triangle this way, right? There's nothing wrong with doing your triangle this way as well. There's kind of like 2 options, right? We could have made it this way as well, and that's fine. Now I erased my force of gravity. There we go. Okay, so if I was to talk about those 2 components, one would be called, I'll put it down over here, one would be called FG perpendicular, and one would be called FG parallel. So this is my perpendicular one here, and my parallel one, which somehow I think I erased the name of, this little one over here, would be FG parallel. Now, when I draw my equality marks here, I'm just going to erase some stuff. Erase these colors so I can get at it better. Now when I draw my equality marks, it's so much easier. Here, I'll just get this FG, and I'll put this one here as FG perpendicular. All right. The car is stationary. It's not accelerating in any direction, so the forces should be balanced. So now when I draw my equality marks, this force here is going to be equal and opposite with that force, with the component, the perpendicular component of the force of gravity. This one will balance out with this one, so I'll put 2 ticks there and 2 ticks there. And now that I look at it, it does seem to be pretty close. Just to make a bunch of short videos, I'm going to cut this one off now, and I'll pick up example number 2 on the next video.